Good afternoon or good morning, everyone, depending on where you're joining us from today. My name is Sean O'Flaherty, and I am the Interim Executive Director here at SCR, um, Eastern Canada. And today we're joining Patrick Nussey and Nick Mazany-Wright for their webinar on Emerging Aquatic Connectivity Conservation Tools, the Canadian Aquatic Barriers Database, and Canadian Aquatic Connectivity Assessment Webtool. So I'd love to just give you a little bit of information about SER before you begin, as some of you may be new to our work and what we do. SER, or the Society for Ecological Restoration, is a global organization that advances the science, policy, and practice of ecological restoration to sustain biodiversity, improve resilience in a changing climate, and reestablish an ecologically healthy relationship between nature and culture. One way that we achieve that mission is through our chapter's webinar series. SER Eastern Canada typically offers 4 to 6 webinars per year from a wide variety of speakers who are involved in the field of ecological restoration, and we offer webinars in both English and French. Our global organization, SER, offers 2 to 3 webinars per month on their end. To browse upcoming webinars, view existing webinar recordings, and find information on our many resources, we invite you to have a look at the website www.ser.org. Now, today's webinar is being recorded and will be available for future review on our YouTube channel. The session will run for about an hour in total, and everyone here is muted, but you can type your questions into the Q&A box at the bottom bar, and the speaker will address specific questions from you after the presentation. So please don't hesitate to ask questions throughout the Q&A at any point during the session. And to assist our speaker, we ask that you keep your questions concise and related to today's presentation. Please feel free to ask your questions in either official language of Canada, English or French, and we will make sure that the question and answer is translated if it comes in French. Now, before we begin, we need to inform you of some important guidelines to ensure the integrity and respect for the intellectual property of our presenters. These measures are in place to protect the copyright material of our presenter and pertain the integrity of the content that they are sharing with us today. Please be advised that recording this webinar in any form is strictly prohibited. This includes, but is not limited to, audio, video, and photographic recording. Utilizing any external software or tools to record or transmit the content of this webinar is also strictly forbidden. You may notice that the use of AI or artificial intelligence tools or assistance during this webinar is limited to the individual viewing the webinar, and AI should only be used for the purpose of increased accessibility or support for the individual viewer. Any products of an AI tool or assistant may not be shared or publicly disseminated. In this webinar, AI-generated captions are available for today's webinar in English and French, and you can enable this on your end on the caption button on your end. Should you require a transcript of this webinar in English, please feel free to request one via info@ser.org. We're more than happy to provide this to you for your personal use and reference. And we'd like to thank you for all of your understanding and cooperation. Now that housekeeping's out of the way, I'd love to give you a little bit more information about today's speakers and our presentation topic. So on behalf of the Society of Ecological Restoration, Eastern Canada, I would like to thank Patrick Nussey from the Nature Conservancy of Canada and Nick Mazany-Wright from the Canadian Wildlife Federation for joining us today. Patrick Nussey on his end works with the Nature Conservancy of Canada as the Manager of Conservation Science and Planning across the Atlantic region. Pat grew up in rural New Brunswick, where he developed his keen appreciation for nature. After completing his education, he spent the next few years traveling around the world and contributing to conservation projects. His travels inspired him to continue working in conservation closer to home, which ultimately led him to his current position with NCC. On his end, Nick Mazany-Wright works at the Canadian Wildlife Federation as a senior spatial ecologist. Nick has a background in geospatial analysis and the restoration of freshwater and wetland ecosystems. His work includes using geospatial models and conservation planning tools to assess, prioritize, and restore freshwater connectivity in aquatic systems. But you're not here to listen to me, so I'd love to pass the microphone over to Nick and Pat now, and you may go ahead and begin your hosting. Abir, you can stop the sharing of the screen on your end.
Thanks, Shauna. Share my screen.
We can see it.
Great. Yes, we're and I are excited to be here today to talk about some of the work that we've been doing to develop these tools to support aquatic connectivity and restoration efforts in Canada. Shauna mentioned today we're going to be talking about Canadian Aquatic Barriers Database, a standardized, centralized, and open national database of aquatic barrier data in Canada, and the Canadian Aquatic Connectivity Tool, which is an innovative web-based tool that is being developed to make aquatic connectivity assessments accessible and help identify, assess, and prioritize aquatic barriers for potential removal or modification. But just before diving into the tools, we just want to talk about aquatic connectivity quickly to make sure that we're all on the same page when we talk about aquatic connectivity, freshwater connectivity, aquatic barriers, and we have a shared understanding of the definitions. So aquatic connectivity or freshwater connectivity generally refers to the ability of fish and other aquatic species, nutrients, and energy to flow freely within freshwater ecosystems, rivers, lakes, wetlands, without the physical disruption of this movement by barriers. And connectivity is vital for maintaining processes like fish migrations to important habitats to complete their life cycles, distributing food sources and nutrients throughout the system, and regulating water temperature. Unfortunately, as many of you will know, in many freshwater ecosystems across the country, aquatic barriers disrupt these processes and disconnect portions of our streams, rivers, and lakes. And freshwater connectivity has been declining in Canada in recent decades and is identified as a threat to many aquatic species at risk. So when we talk about an aquatic barrier, it's really any structure that disrupts that connectivity of these aquatic ecosystems. And it can, in the broader definition, include both natural features like waterfalls that are natural barriers to fish passage and human-made features, things like dams, stream crossings, culverts. And from a conservation perspective, an aquatic barrier is generally considered based on its effects on fish passage. So can an aquatic species move freely past this feature? And so human-made barriers are primarily the focus of prioritization efforts to restore aquatic connectivity. And so that'll be the lens through which we focus on aquatic connectivity during the talks today. So starting with the Canadian Aquatic Barriers Database, or the CABD, this is a product that CWF has been developing since 2019. And as I mentioned, the vision for the CABD is to kind of be a one-stop shop for aquatic barrier and connectivity data in Canada. So all of Canada's aquatic barrier and freshwater connectivity information in one place, easily and openly accessible. And CWF was interested in creating this product because we were moving into creating a national freshwater connectivity or fish passage program. And we realized that while there's a lot of great barrier data sets out there, they're splintered across the country. There's a lack of standardization. They often focus on single barrier types as opposed to the suite of structure types that can affect aquatic connectivity in Canada. And we know that these structures fragment these systems. We know that they block habitat, and we know that there are a lot of them in the country. But we didn't have answers to some important questions. So some of the things that we didn't know were how many exactly of these barriers exist in Canada, how much of the habitat for freshwater species is not accessible currently, and how do we identify those most important barriers to target for removal or replacement in order to maximize the return on investment when we have scarce conservation or restoration dollars. So we came to the conclusion that we needed a comprehensive information source to answer these questions. And to answer these questions, we developed the CABD. So the CABD owes its existence to existing data sets across the country. We started with spatial data sets. We compiled those. We deduplicated. We standardized. We brought them into a new data structure in the CABD. But since then, we've actually compiled over 800 different data sources from across the country to form the CABD data sets. And we have data on dams, waterfalls, stream crossings, and fishways. So currently in the CABD, we have 36,000 plus dams across the country, 25,000 waterfalls mapped, unfortunately, just over 400 fishways on these structures. And we just a few months ago released our first version of a stream crossing data set. So anywhere where a road, rail line, or trail crosses a stream, we think that there's some kind of structure to get that infrastructure across, and some kind of structure to let water pass through. So there's 1.5 million of these in Canada, which is a really big number, but these are just modeled at this point. So anywhere where there's an intersection point, we think there might be some kind of structure. Based on work that we've done at watershed and local scales, we know that many of these structures will be passable. Some of them might not exist in reality on the ground, and many of them will also not be on fish habitat. They'll be higher up in the headwater systems, where fish don't make use of a lot of those streams. We're currently working to compile stream crossing assessment data from across the country. We already have thousands of assessments that we've brought in, and so we're working towards the release of Stream Crossings version 1.1, which will start to include that assessment data, and we're hoping to continue to work to fill data gaps, so that we know how many of these stream crossings are actually going to be impacting fish passage and connectivity. So, as I said, we've been working on this since 2019. I think the first version of the CABD was released in 2023. And since then, a number of groups across the country have used the CABD for a number of purposes. Groups like DFO have been using it for habitat status assessments and reporting. There's also been some utility in using the structure data to inform management and regulatory decisions around infrastructure management for some of these aquatic structures. As we'll see today with the CANACT tool, restoration planning and prioritization is one of the main use cases for the CABD data. We've also been able to contribute to research and monitoring initiatives across the country when they're related to aquatic barriers. And we also view the CABD and the CANACT and other related tools as an opportunity for education and public outreach around the effects that these structures have on freshwater ecosystems, and how we can start to restore fish passage and connectivity across the country. So the CABD, the database, the data is available through a web tool at aquaticbarriers.ca. You can visualize the data on a map. You can search by an ID, a structure name, a place name, a location. You can play around with the layers if you want to look at dams, waterfalls, fishways, model crossings. We also have watershed boundaries in the tool as well if you want to focus some of your searching or data downloading on a particular area. If you click on a barrier, you'll be able to see the information that we have about the structure. So this is the St. Mary Dam near Lethbridge, Alberta. So we have a number of attributes that we collect and make available where we have them. You can also filter the data by geography, so by province or territory, or by those watersheds that I talked about. And you can also filter the data on a select suite of attributes, things like passability status, ownership type, size, things like that. And then you can also download the data. So you can either download the entire data sets, or you can download data that you filter down to a particular geographic subset, or based on some attributes, and you can download those in a number of formats: shapefile, geopackage, KML, CSV. And this data is open data, so it's free to use as long as it's attributed. And then finally, a relatively new feature that we've released is we actually accept information updates through the web tool itself. So if you click on a point and the attribute pop-up comes up, there's a little update this information tab, and you can give us some information just so that we can contact you if we have any questions about the information that you've submitted. And then you can just, in the text box at the bottom, give us the information that you have. So if we don't have, say, a dam name or a dam height for a structure in the database, you can say, I know that this dam is called XYZ. That information will be submitted directly to the database. We'll review it, and we can use it to update the data sets and start to fill those data gaps. So, important caveat. Are these CABD data sets perfect? No, they are not. We know that data gaps exist. We know that we're missing structures. We know that we probably have structures mapped that don't actually exist in reality. And we don't have attribute information for a lot of structures. For many across the country, they existed in some spatial data set maintained by a province or a local group, and all we have is the point and not a lot of other information around that. But is now the most comprehensive and standardized data set available nationally for these aquatic barriers in Canada. And we're always continuing the work to fill those data gaps. And since we first launched the CABD, we've already, through various means, been able to add information for over 7,000 features, and that number grows every day. And we're also developing some tools to help us fill those data gaps so that we can improve the quality of the data set. Our intention with the CABD is to maintain it in perpetuity. We don't want this to become one of those data sets that becomes a legacy data set and doesn't get updated for 10 years and isn't current and becomes less useful for informing work and analyses. So one of those tools that we're working with partners from across the country to develop is a national stream crossing assessment protocol. Many provinces and organizations at watershed or local scale do have existing barrier assessment protocols, but there are many regions where there isn't a widely used protocol, and we wanted to be able to fill that gap, as well as collect information in a way that can be fed directly into the CABD without having to do data transformation or crosswalking. And so we've worked over the past 2 years with a working group of practitioners and experts from across the country to develop a passability module for a national stream crossing assessment protocol. We're currently at the phase where we've just finished up the draft field sheet, and we're going to do some field testing of the field sheet and the guidance material this summer, and we're hoping to release this publicly and have it be available start at the start of the field season in 2026. So having these professional assessments that require equipment and some training will really help us fill those data gaps for stream crossings, help us get at whether these structures on the landscape are in fact affecting fish passage or not. We also want to cast a wider net as well. And so we are in the process of developing a community science rapid assessment mobile app. Some of you might be familiar with iNaturalist for species observations. You can think of it as an iNaturalist type app for aquatic barriers. And so this isn't intended for professionals or trained volunteers. The goal is to turn every Canadian into a community scientist and help us collect this information on the structures. There's no equipment needed. All you need is your mobile phone. And from the side of the road or the side of the stream bank, you can answer a few quick questions about these structures, take some photos, that gets submitted to our database, we process it, and we can make that information available and update it in the app. And so we're developing an iOS and Android version of this app. We did some field testing of it last summer, and we're currently in the final phases of development, just making some final tweaks. And we're hoping in the next couple of months, we'll be able to launch this app to the public. And so you can walk on your walk or your kayak, or if you're going angling, you can have your phone with you, pull up the map on the app, assess the structure, answer some quick questions, and help us fill those data gaps. So we're really excited about being able to start to collect information that way and crowdsource the filling of data gaps across the country. So the reason we started with the CABD is because it is the foundational data source for the Canadian Aquatic Connectivity Tool, or CANACT, which will be the main focus for the webinar today. And we're really excited about this tool and being able to make it available to the public. But essentially, just to help understand the connection between the two. So we have the data in the CABD, which has the barrier locations and some of the basic barrier information, name, passability status, height, ownership, things like that. That data is made available through an API, which is essentially just a menu that an application can connect to that allows you to pull information from a database without actually having to download and manually load the information into your tool or whatever analysis you want to do it for. So that information is automatically updated to the CANACT every time the CABD is updated. And then the CANACT, which Pat will go into more detail about in a second, calculates barrier metrics, runs prioritization scenarios, and you get an output that gives you prioritized barriers tiers. And then we have those tools and those methods that I talked about, whether those are field assessments, the community science mobile app, or just sending us an email telling us, we have information about some structures, we can make those updates. Those go back into the CABD. That data gets pushed to the CANACT. The tool is rerun and new prioritized metrics are available. So again, this is not intended to be a static tool. It will continue to evolve and be updated over time so that when you're using the CANACT, you'll always have the most recent and most up-to-date information available to you. And just, from our perspective, we worked with Pat and NCC closely on developing the CANACT, and we're really excited about it. And so one of the things that we want to explore is rather than having a CABD web tool and a CANACT web tool, we'd like to pursue more direct integration of the two tools. So it's kind of a one-stop shop where you can both explore and download the data as well as run online prioritizations. And so there's some examples of that with groups that have similar tools in the US. And so we're hoping to seek additional funding in order to do that more direct integration. And with that, I will hand it over to Pat to talk about the CANACT.
Great, thanks, Nick. I'm just going to have a little swap of presenters here. Great. Okay, yeah, so thanks, Nick. So carrying on from that, it's, seeing all the great work that Canadian Wildlife Federation has done with the CABD, it seemed a great opportunity for our two organizations to partner on developing some of these tools. And so I'm going to go over a bit today on the Canadian Aquatic Connectivity Tool, a little different name than what we had originally proposed, but it seemed to be a nice snappy name with CANACT, so we're going with that. And so this is an aquatic barrier prioritization and decision support web tool for practitioners interested in assessing barriers for potential removal or remediation. So a bit of context as to where this came from. Back in 2019, the Nature Conservancy of Canada had developed the freshwater aquatic blueprint. And the aquatic connectivity tool was actually one of the 5 key ingredients to that suite of aquatic conservation tools. And so through that process, we had developed a stream classification. We had looked at a watershed health assessment. We developed an active river area modeling exercise, so modeling the functional riparian area for aquatic networks, just to kind of give kind of a more focused version of the terrestrial areas contributing to aquatic health. And so that is one key part of the tool, as you'll see in this presentation. And we'd also developed a freshwater climate resilience assessment tool, and finally, again, the aquatic connectivity tool. However, at that time, it was a GIS-based assessment tool, and so it could only be used by the practitioner if they had expertise in GIS, and so we wanted to make that a little bit easier. But the original conception of this work did come from the Northeast Aquatic Connectivity exercise and work that had occurred in the Northeast United States with the Nature Conservancy, the US version. And so we've kind of imported a lot of that work across the border. But again, with that originally being a GIS tool only, there were a few shortfalls into the accessibility and utility of that tool. So for one, you needed an ArcGIS license to run it. You needed expertise, pretty significant expertise in working within ArcGIS to be able to get good results. It was also based on static data layers, so there'd be uncertainty in whether or not you had the most up-to-date barrier information. That's where the CABD now comes in, and it was a quite time and effort to create those results. And so the next big step was to bring that into a web-based tool where we can replicate that functionality that we had in the ArcGIS version. Right now, it's much more accessible. It's available in a web browser. You don't need any additional software to run it or additional GIS training. It's a quick and intuitive point-and-click functionality, very easy to use. We take that burden of data management off of the user. That is now rests with the Canadian Aquatic Barriers Database that Nick talked about earlier, where the data is directly pulled into the tool with the most up-to-date versions. And the idea is to make it more, to increase that performance and speed of giving you those good results. We can now visualize those results in a map that can be downloaded and shared with other users and practitioners as well. So I'm going to go over some of the inputs that go into some of the calculations that are used in prioritizing these barriers. But first, I just want to talk a bit about the scope of the project. So right now we're running the initial pilot. And so we do have information. What you see on the map here is the scope of the current version of the Webtool. So these are all the watersheds of the Acadian Appalachian ecoregion for the Canadian portion. But as you can see, some of those headwaters do dip down into the US. And so those are also pulled in just to make sure we have the full picture of the entire watershed. And so you can see goes down into Vermont, and then in parts of Maine with the headwaters of the St. John River are also included. So I know we might have some folks on the call from outside of this region. Unfortunately, you have to be a little patient. The long-term vision is to make this available across the country. But right now we're just focused on this priority focal area here to make sure everything's up and running smoothly. And then the anticipation, funding dependent always, is to expand this to other regions. But back to some of the inputs, the base hydrography for this is that NCC stream classification that I discussed as part of the aquatic blueprint. The reason for this is it's very difficult to use current publicly available data sets for stream networks, because you do need a fully connected network to make sure that this runs properly. And so some of the existing data sets, the National Hydrology Network, for example, does have some loops and breaks in the connectivity of those stream networks, which can cause some issues in giving you accurate results. And so we spent a lot of time within this region correcting a lot of those disconnections to make sure we had a good fully connected network. There is on the horizon a version 2 of the National Hydrology Network that we're anticipating to be released, which may address a lot of these issues. And so we'll be able to update the tool with that newer data set when that time comes. But for now, we rely on this data set. Again, the aquatic barriers come from the CABD. And so as that information is updated by the submission of new information, that gets reviewed and incorporated into the data sets by the Canadian Wildlife Federation. And then that information is pulled directly into the prioritization web tool. There's some land cover metrics that we look at. So we have created this composite land cover to kind of get a sense of the condition of the watersheds that the barrier is based in, the upstream watershed from the barrier. We use that as a surrogate for aquatic health to determine the level of disturbance on the landscape contributing to the aquatic health of that particular stream. Again, we use the active river area. This is the functional riparian area delineation. So we're looking at areas, kind of wrapping up everything into one single layer, looking at floodplains, riparian wetlands, looking at steep slopes and sediment and material contribution areas along streams. So a more focused way of getting at aquatic health. And then just a general disturbance layer, looking at human footprint to determine the relative impact on those watersheds. We also want to know the presence of aquatic species within the watersheds that particular barrier might be found in. As part of the aquatic blueprint, we pulled together 35 different data sources and tried to create this composite layer of aquatic species presence. And so within that layer, we now have around 90,000 fish observations, a few crayfish, and a few thousand freshwater mussel. This is a data layer that we'd like to see updated. This is a 2019 version. There is lots of data out there on this. It's just a central repository for this type of information would be extremely useful. So if anyone on the call is interested in taking that on, we'd be more than interested to chat about that, because it is important that we do capture the current picture. We also want to know where some of these barriers exist and whether or not they're on conservation land. If a high priority barrier does happen to exist on a protected area, the mechanisms for restoration may be a little more straightforward. And so we kind of want to bump the priority of some of those barriers if we can. So that's the data that goes into the barrier tool. Now I'll talk about some of the metrics that are derived from those data sets. So we're looking at calculating a lot of information on the dendritic network itself. So these are kind of more length and distance measures of upstream functional network. So functional network being that from the barrier that we're investigating upstream to the next barriers, that's your functional upstream. Functional downstream would be downstream to the next barrier. And then the total functional would be that space in between. And so we calculate a lot of these different barriers that you'll see will go into a weighted sum of all of these metrics to produce that final prioritization result. Again, like I said, we use some of those spatial data sets to look at the watershed condition, looking at development in the upstream watershed or versus natural land cover. We want to look at within the active river area, that level of disturbance or intactness, whether that barrier is on conservation land or not. We also want to look at the forested, the proportion of the upstream watershed that's forested, whether or not there's agriculture in that watershed. And then again, that human footprint, just to get that general idea of relative intactness or disturbance of the upstream and downstream watersheds. And then with some of the species data, we want to look at the ecological benefit. So we need to know if there's diadromous or anadromous, migratory, non-migratory fish present in those watersheds where those barriers are found. We look at some additional taxa of crayfish and bivalves to make sure that we're getting that species richness that we want in a fully connected network. And then lastly, we're looking at some stream habitat, stream diversity. So looking at prioritizing barriers that might be found on stream networks that have a little bit more diversity in their size distribution as a surrogate for kind of the diversity of aquatic species that might inhabit those networks. We're also looking at prioritizing streams with cold and cool water habitat, obviously important for this region, in particular with our diadromous fish species that depend on those cold water streams. And then Nick kind of touched on this briefly, but just how everything's working. Like I said, the data is all maintained in the CABD. Once new information becomes available to the passability of a particular structure, that information is uploaded to the CABD. The metrics are then rerun with this new information and fed back down into the barrier prioritization web tool. And so that allows our prioritization scenarios to be run very quickly in near real time by the user. We have a couple of default scenarios that are included in prioritizing. So we can either prioritize, the default scenarios are for diadromous fish species, so our migratory fish species, Atlantic salmon being the kind of keystone one for our region. And then, like I mentioned before, those metrics are summarized and added, it's summarized by a weighted sum. And so you can see in this example here, the different weights that are placed on different metrics between diadromous and resident fish species. So these were developed initially through that work that I mentioned earlier in the US. We did some workshopping in the early days of developing the GIS tool, just to make sure that this made sense for our region. And then the final weights were kind of agreed upon. And so now we have these default scenarios embedded into the tool. So it makes it very easy for the user to decide how to proceed with their prioritization. So now I'm going to switch over quickly and give you a demonstration of what the tool looks like. So once you go to the web page, you'll be greeted with this splash screen. Just wanted to make give some kudos to our funders for this project, primarily the province of New Brunswick, Governor of New Brunswick, and the Pescabacati Recognition Group, also operating out of New Brunswick through their funding through the Department of Fisheries and Oceans, as well as RBC Foundation has provided funds to CWF to help out and partner on this project as well. So here you'll find a little bit of background information. We'll have a user guide also included with this once the development is complete. So when we look at the page, this is the web tool. We've got a few sections here to look at. your kind of the area where you're doing all your making the settings and doing the prioritization here on the left. We've got the main map on the central screen. We've got the legend and some layers here that you can turn on and off as you wish to just have those displayed in the map. This is available in both French and English with this toggle here. If you're working in French, we've translated the entire site, and so you just have to switch this over to French if you want to work in French. Across the top here, we've got the kind of the step where you are in the process of prioritizing barriers. And so the first step is your scope selection. So this is the geography that you're selecting to where you want to do your assessment. And so we've got a few options here. At this point, we've got, you can do it at the scale of the province. Although again, the larger the area you do, the more demanding the processing is. And so not recommended at this scale, but it is still possible. You just have to be a little more patient with the presentation of those results. And then we have a hierarchical embedded watershed network here. So we've created these Canadian hydrological units, we're calling them, another development out of the aquatic freshwater blueprint. And so we have different size watersheds that we can look at. So for example, with the CHU4, this would be the entire watershed of the St. John or Willistock River. And then going down from there in size, we can kind of go down through. They'll be displayed in the map, the boundaries of those watersheds. So for the purposes of the demonstration, I'm going to select Canadian Hydrological Unit size 8. And we'll go down here, Passamaquoddy Bay East. So you just have to select your watershed by clicking on the map. And then you'll be presented with a summary of the structures that occur within that watershed. So for example, within this watershed, we have 797 potential barriers. So this would be a combination of dams and stream crossings. If the work has been done, I'm selecting this one because there has been a lot of work by the Passamaquoddy Recognition Group and doing an assessment of a lot of barriers. So far, based on the CABD data that's coming in, they've assessed 308 of those 797 barriers. There's been 3 barriers removed, so we're also trying to track that information. And then we just have the number of dams and number of stream crossings. Again, these are a combination of field verified stream crossings and modeled crossings. So you can choose 1, you can choose 2. It'll update your summary here based on the number of watersheds you choose. So once we have our watershed selected, we just go in, confirm. Just a quick reminder here that what you see on the map, there's more detail, so you can zoom in to get a little bit more information. And so if we zoom in, you'll see a lot more barriers start to appear. So what we see on the map now is all the dams, waterfalls, and stream crossings that occur within this watershed. And we have a lot of assessed ones that have been deemed passable. So if you pay attention to the legend here, the size is the structure type, and the color is its passability status. Green being passable, red being a barrier, and purple being unknown. So like Nick was saying, is it perfect? No, we have a lot of unknown passability status. At this point, we're treating all potential barriers as barriers. And so as new information does start to roll into the CABD with using with the app that Nick had mentioned, these statuses will be updated to reflect the information that's going in. And so this is where we run our prioritization. Again, I mentioned those default scenario types. We have the diadromous, we have the resident, or if you like, you can choose your own custom approach. These are the weights that go into the metrics. And so the default ones already have the weights put in. So there's 35 metrics here that we can calculate. Or you can enter your own weights as long as they add up to 100. Then it'll work just fine. So if you need a little bit more information on what all of these mean, we have all of these icons here that'll tell you what's the definition of these metrics. So for the purposes of the demo, we're just going to run a default diadromous or migratory fish species prioritization that will make use of the default weights on these attributes. Once we're done there, we just click analyze. And within a couple of seconds, we should have our results. And now we have our results. Again, at the top, it tells you where you are. And so what we've done here is we've broken down the scores that are the weighted sums of all of those barriers that you see on the map into 5% bins. And so if I move this slider, you'll see barriers start to disappear on the map. And that just means these are the higher and higher priority barriers based on the results of those calculations. And so if I go to tiers 1 and 2, this basically means the top 10% of scoring barriers within the scope that we had selected initially. And then if you want to kind of widen that, if you go to 4, so there's the top 20% of scoring barriers. Just to keep in mind, barriers that have been assessed as passable are not included in the prioritization. We don't want to prioritize or include those passable structures. We just want to focus on ones that can make use of restoration and remediation to improve fish passability. We have a number of filters here as well. If you really just want to focus on those high priority dams, we can turn off everything else. And then we get a few dams here that have come up in the top 20%. You can filter by passability status. You can filter by assessment status. So if you want to know if that barrier that's been prioritized has already been assessed, you'll have that information. And this can help with your field planning. So, prioritizing those visits to the higher scoring barriers can help increase the efficiency of some of the field work that you want to carry out. So a bunch of different filters. You have the option. We can download the results of the prioritization in a few different formats. And another thing we can do is what's helpful is the common ID that exists between the CABD and here. You can actually search for a specific barrier if you want to see what that looks like. So for example, with this barrier ID, we've zoomed into this dam right here. And then what we can do then is click on that dam and get a little bit more information. Some of the information is pulled from the CABD, and the other information is calculated within the Webtool as you see it here. And so we've got a couple of different tabs here that we can choose. But the first thing to look at is it's going to map your functional network in blue. So from that barrier up to the next barriers upstream, you get your functional network mapped. And then the total upstream network is beyond those barriers, just to give you a sense of what's upstream from that barrier that you're looking at. Again, we can tell whether or not this barrier has been already assessed in the field, and a few other information that's pulled from the CABD is pulled into here as well. In addition to that, we have all the metrics that were calculated down the left-hand side here. So some network stream length metrics. So we can look here. The total upstream network here is almost 10 kilometers, 9,800 meters. And then we have all of those metrics calculated here that you can review. So we have our percentage, natural land cover, 96%. We have 78% of that, 79% is forested. We have a small amount of agriculture in that upstream watershed. And so these are the watersheds calculated from beyond the barrier point. And so that's that. Quick demo of the tool. As far as next steps go, the original intention was to kind of treat this presentation a little bit as a launch and to make this publicly available. Unfortunately, in the time between when we said that and now, we've discovered a few underlying issues with some of the metrics calculated within the tool. So we're busy on the back end trying to fix those up, but our intention is to make this fully publicly available within the short term. Again, I mentioned this is just a pilot project for now within the scope that I had showed you earlier. The long-term vision is to expand this across the entire country, but we are going to be heavily looking for funding to do so. But yeah, I hope that was a good introduction to what this tool can do. We're really excited for this. This is the first web tool of its kind in Canada. And so really excited to be able to partner our two organizations together to deliver this product. We think it's going to have a lot of value into the future. So I think we might stop there, and we have some time for questions.
We certainly do. Thank you so much. That was really interesting, Pat and Nick. I could look at map stuff all day. I always think it's really neat. And when you're talking about aquatic barriers to fish in the Atlantic provinces, you've really touched upon something that hits very close to home to a lot of people in that region. We did have a couple of questions come in so far in the chat. If the people in the chat don't mind, I'm happy to read them out in English. They've all come in English so far, but if anything comes in French, we will translate for our two presenters. So the first question came in from Vincent Theriot, and speaking of French, he wants to know for the translation in French. I think this one was addressed more to Nick, but you're both welcome to answer. For the translation in French, who have you partnered with, and would you like to get more support from Francophone practitioners?
Yeah, great question. I can speak to the CABD for our translations there. We actually have an internal translation service in our organization. So everything that we want translated, we put it together into a document and we pass it along, and that gets translated. In terms of more support from Francophone practitioners, while I think our translation service does a great job, there might be some mistranslations, or maybe because they're not technical practitioners or translation folks, they might have used a general translation word as opposed to a specific technical translation. So certainly we'd love to get feedback from any Francophones exploring the tool on ways that we can improve the French translation and accessibility to Francophone Canadians.
And how would they provide that feedback if they do come across things that need a little bit of an updating in French?
Email would probably be the best way. I can put our CABD email in the chat.
And the same would go for the connectivity web tool. We have internal translation services as well, but obviously there are some words that are kind of outside the expertise of, some contextually important translational words. So yeah, we're always looking for that kind of feedback. There'll be an email address associated with the splash screen that came up at the beginning of the presentation. So that'll be available, and we're always interested in getting that kind of feedback.
Always great to see more bilingual or multilingual scientific tools, as science has been so streamlined into one language only so far. So I think I have two questions here from Charles Latremoy. The first one goes out towards the Canadian Wildlife Foundation. So is there a recurrent funding in place to ensure that this database will be maintained in the future, or does it rely on continuous fundraising efforts?
That is a great question, and for an NGO and charity like us, it's always a big question: is how do we continue to fund these projects? We're very lucky in that the organization sees a lot of value in the work that we're doing, and so we are committed to if we need to use CWF funds to maintain the database. So that would mean accepting updates, continuing to update, but not necessarily pursuing further development, adding new features and things like that for some of those new development projects that we might want to do, like direct integration with the CAN Act and things like that. It would depend on us continuing to seek funding. But we have a really great relationship with the RBC Foundation, who've funded us for 5 years now, and we're actually working with them on a new funding agreement potentially. So I'm optimistic that we'll be able to continue to develop this, but we do have a framework in place to continue to make sure that it's at least maintained and kept up to date over time.
Perfect, thank you. And another question coming in from Charles Latremoy. Charles wants to know if there's a web service to access an up-to-date CABD dataset in various GIS applications, together with other layers that you can use.
Yes, so we do have an API for the CABD data, which the CAN Act tool uses, but that is a publicly available API. So we actually have a documentation site for the CABD that I can share the link to. It provides a bunch of information about the CBD, the data sources, provides data definitions for all the attributes and things like that, but it also has a section on how to submit an API request and access the data. So that would be the best resource for that. And if you have any questions, you can always email us for questions. But that is one of the goals that we wanted to do with the CBD, is make it as accessible as possible so people don't have to download static data sets and manage them in isolation. So yes, the web service is available. The documentation site covers how to do that, but we're always happy to answer questions.
I think I just popped the link to that in the chat. Please make sure it's the right one.
Yeah, looks good.
We have a couple more that are coming in online, some comments, but I had a question as well. You noted that you can open, the tool is open for updates for submissions, and I wanted to know how things were vetted from the various teams. It's a very large country.
Yes. So there was a few stages. So we started with spatial data sets, and we realized very quickly that for one dam, for example, it could exist as a point in 8 different data sets across the country. But there was, the name, the height in one, the use in the other. So we did some standardization, crosswalking to make sure that we got all of those attributes in there. Then we did our own searching based on stream name and dam name to find any additional information from non-spatial resources that we could, and we brought those in. And we kind of have a hierarchy of precedence for the type of updates that we get, whether it's a federal or not, or provincial database. Those are higher up the list versus a blog post that gives a waterfall name. We're going to put a little bit of trust in if we have conflicting, a little bit less trust in if we have conflicting information about a name. But in terms of updates that come in from Canadians through the Webtool or hopefully through the app, we have technicians on staff who do a review. We check it against the information that we have, and the reason why we ask for an email along with the submission is so that we can get back in touch with whoever submitted that information if we have any questions about it. So it's not a perfect system, but we do review each submission before we finalize that information and move it into the Webtool.
That's always the big question with citizen science, is the vetting, isn't it?
Yes.
We have a couple of comments here. One is from Lynn Rochefort, who's the co-president of our chapter. She's just very interested in the tool and is excited to promote it within our larger chapter and our upcoming symposium. So thank you very much, Lynn. And Charles, who's already asked a couple of questions, just very excited to use this on his upcoming bike rides this spring and summer. So I think you've got some devotees already. Allison Moody worked on the US version of this kind of data and websites, so she's also really excited to see this up in Canada, since we've got so many lakes, streams, rivers. We're just the freshwater capital. We're going to go back to French stuff and French questions here. So I have Alexandre Racilius. I apologize if I mispronounced your name, Alexandre. Who says that there's a large need for data on the Quebec side of the aquatic connectivity tool, especially when it comes to stream crossings. The Fondation de la Faune du Québec has funded several projects in that region, which is the lower Bas-Saint-Laurent region adjacent to New Brunswick, that have, amongst other things, evaluated the connectivity amongst hundreds of these crossings. So I think he's looking to know how much integration you're trying to get between the different provinces.
Yeah, we're looking to get any information that we can, and as I said, we're kind of in the process of putting together a version 1.1 of our stream crossing, and hopefully move away from purely model crossings to ones that have been assessed. So we've tried to identify just through web searches and stuff any organizations that we think might have assessment data, but we know that that's not going to be the full scope of organizations across the country that do have that data. So it's great to publicize this work in a forum like this, so that people like Alexandre can say, hey, we have some data. So yeah, Alexandre, you can send us an email, or I can get in contact with you and love to chat about how we can access that information.
Thank you for that comment, Alexandre. I'll share your email at the end with our two hosts. Martin Lafrance wanted to know if there's any planned timeline for extending the online aquatic connectivity tool north of the St. Lawrence River in the province of Quebec. And also congratulations on all the hard work.
Great. Thank you, Dan. Yeah, so there's no timeline currently for the expansion. Right now, the focus is on trying to get everything functional at the scale that we have it now. Obviously, beyond that, the intention is to expand the scope. Again, that's working for NGOs. It's always funding dependent, but we do have a lot of buy-in from some significant funders on this project. So we hope that can continue. It's also dependent on some of the input data sets. And there's quite a bit of work to be done on the hydrography network data that currently exists and ensuring that it's a fully connected network, so it's functional in the tool. So there are some upfront things to address before we can expand the tool, but the timeline is not set right now, but as soon as we can, we hope to do that.
Perfect. Well, it looks like our questions have sort of trickled to an end, so I'm going to start wrapping this up if that's okay with the two hosts, who I'm sure do not mind getting back to their extremely busy days. But I'd like to thank Patrick and Nick for an excellent presentation today. We really appreciate that you took the time to speak with us and prepare this presentation beforehand. And we'd also really like to thank all of you who were able to attend today's webinar. To any of our certified restoration practitioners out there who are in attendance today, this webinar is pre-approved for one continuing education credit through SER. If you do require a certificate of participation for CERP credit, please email serec@ser.org. So that's serec@ser.org, and we can provide that to you. We also encourage everyone to visit the SCR website to see a list of the upcoming webinars, to learn more about our work, and of course, the benefits of membership with our organization, as it's through our members that we're able to offer such quality programming. Additionally, a recording of today's webinar will be available soon on our YouTube channel, which I'm going to go ahead and add right now into the chat tool. Too many screens here. Some of you are already subscribed, but we go ahead and try and upload this in the next couple of days. So I'd really like to thank everyone who's attended today, and hope that you all have a wonderful rest of your day. I'd like to thank our hosts, and on a personal note, I just want to thank everyone, as this will be the last one I'm hosting for SCR, and our new coordinator, Abir, will be taking the microphone from here on out on future webinars. So thank you, merci, bonne journée, thank you.
Thanks, everyone.